Now, today we are going on to something called scalar multiples of a vector. Okay, what do you mean by scalar multiple? I'm going to show you on the board first what we mean by that. Okay. Now, class, if this is vector A, right? Don't talk. If I want to draw vector 2A, it must be parallel and the length must be 2 times. Do you understand? What if I want to draw vector half A? It must be parallel and the length is half of this. We are just talking about scalar multiples. Everybody clear? Now, what if I have something like this? Then what will this vector be? Negative 2A, correct? The negative is just the direction. The number is how many times? Everybody okay? Everybody okay? Alright, Okay, now, let us take a look at this part here, at the bottom here. Alright, this one illustrates very clearly. Now, this whole thing is A. If here is B, this will be B. Then C will be this, right? Now, can you see that A is actually 2B? Because they are parallel in the same direction. Can you see? And A is actually what? Negative 3C. Can you see what I'm talking about here? It's the same length, but it's the different direction. Can you see what I'm talking about? Okay, alright, now let's take a look at the answer below. Now, A is 2B, alright, and A is negative 3C. Can you see at the bottom there? So, 2B and 3C are called the scalar multiple of B and C respectively. Okay? Now, then you look at this one on top. Now, don't bother too much about this because it's a bit I'll explain to you first. If A and B are two non-zero and parallel vectors, then A equals to KB for some scalar or real number K not equals to 0. Okay, what do you mean by this? I just explain to you what it means. Okay. If I have A equals to 3B, that means I will have the vector A. This will be B 3 times, right? They are equal. So actually these two are parallel. Can you see? Now, even if I have A equals to negative 3B, they are still parallel. Just that it is in the opposite direction. Are you clear with what I'm saying? Okay? So, in other words, A and B are any two vectors. A equals to KB for some real value K. There are 3 possibilities. Either A and B are parallel, right? If their equal is parallel, then A or B is equal to the 0 vector. 0 times anything is 0. Should be the same. Or K equals to 0. That means nothing also. Okay, actually I find that this two is very funny. Okay, don't have to say also can. Understand what I'm saying? Okay? Now, then I want to say, introduce to you a term here, which they say below here. But they say until a lot, I think you may be confused. If A is xy, then KA is kx1, ky, right? And this kind of thing. Okay, I explain something to you first because modulus is out of your syllabus for A maths. Actually, modulus is supposed to be in. Okay. Now, when I have 3, right? I write like this. What does it mean? That means this is the magnitude. This is the number line, right? What is the distance from 0? This is 3, right? Now, then I will have the magnitude of negative 3. It's actually, what is the distance from 0? This is also what? 3. That means this one is just a numerical value. Okay, once you put the mod sign, this is actually called modulus. Okay, but it's not in your syllabus anymore. It's actually in the A-Math syllabus last time. Modulus just means if I have negative 4 is what? 4. If I have 4 is what? 4 lah. That means the distance from 0. Everybody Everybody clear? Now, as long as I have, let's say, V is equals to 3T. T is a vector also. These two will be parallel. Okay? Just that 3 times of T then will give me V. That's all. Okay? As long as you can put that. Okay? Then, what do you mean by this? Now, for example, I have a column vector 2, 4. Then I have another column vector 4, 8. I want to show whether they are parallel. Now, can you see that this is actually 2 times of 2, 4? Can you see? Can you see this is a scalar multiple of this? So these two will be parallel. That means this one will be parallel to this one. Because I can put K times something. Everybody clear? Now, what if I have 1, 2? Are these two parallel as well? Yeah. The answer is yes. Because half times 2, 4 will give me what? 1, 2. Can you see? It's a scalar multiple. As long as it's a scalar multiple of something, they are parallel. Everybody clear? Now, let me give you another example. This is in terms of column vector. Let me show you in terms of other types. Okay? Other types. For example, if I have A plus B as a vector, 2A plus 2B is actually 2 times of what? A plus B, right? So this is parallel to this, and it's 2 times the length. You understand? As long as we can put it as a scalar multiple of it, the 2 vectors are parallel, just that the length is different. Okay, now even if I have negative, this is negative 2, right? It is still parallel, just that they are in opposite direction. Everybody clear? Okay, good. So this is called scalar multiple. Okay, then look at the next page. Alright? Work example 12. I'm going to show you how I look. I don't like the way the textbook does it sometimes, but certain things you have to design in a certain way. Okay? Now, state which of the following pairs of vectors are parallel. Okay, let's take a look at this. All of you look up. Can you see 6, 8 is actually 2 times 3, 4? This is a scalar multiple, right? So, are they parallel? Yes. Okay? Alright? Now, how about this? Part 2. What can I multiply by to get the other one? Are we able to? Are we able to? Are we able to? No, right? We can't right now. I teach you one way to look at it now. You take minus 6 over 8. What does it give you? Negative 3 over 4, right? 3 over 4 is negative 3 over 4. Actually, they are parallel. I teach you something, you listen now. For them to be parallel, right, this over this must equal this over this. Okay, can you see that I checked that they are parallel already? Okay, so how do I show that they're parallel? You cannot do like that, You must tell me that 8 minus 4 is what times this? Do you agree it's negative 3 over 4? Can you see this one I times is 18? I made a mistake already. It's not 3 over 4, what is it? It's 3 over 4, right? 4 over 3 or 3 over 4? Okay, maybe I write the other way around to be better. Can we try this? Correct. Can you see this one? 2 then negative 6, right? Then this one cancel. Can you see it's 3? Can you see this is a scalar multiple and they are equal? Can you see what I'm talking about? Okay, so before we do this multiplication, I want you to do this first to see first of all, are they parallel? If they are the same ratio, right, then they are parallel. Okay, then you can put it somewhere. We eat this up, you just go and figure it out. Everybody can? Can? Okay, then we look at the next one. Look at this one. 50, negative 6, and negative 5, 3. Let's look it up first. Negative 5 over 15 is negative 1/3, right? 3 over negative 6 is negative half. This one will not be parallel. Can you see the ratio is different? Okay, so since 6, 8 is 2, 3, 4, right? 2 times 3, 4. They are parallel, right? Because this is a scalar multiple. Can you see? Can you see? I work it out there already. Okay, now then this one, look. You see, they can put negative 4 over 3. If I don't want, I can also put the negative 3 over 4 here. It's also scalar multiple. Can you see or not? Okay? So they are parallel. Now, then they say this is not parallel because you cannot find a constant k to put there. You understand? So when you work this out, then you will just go and pretend and say, oh no, there's no constant k to put it like that. Okay, so they are not parallel. Everybody clear with what I'm saying? Can or cannot? So you look at here. If they are parallel, then there must be some k that satisfy this. But cannot, won't have. So they are not parallel. That means you just go and tell them you cannot find a k. Understand what I'm talking about? Can or cannot? Can or cannot? Okay, now I repeat what I'm saying. I'll repeat what I'm saying here. All of you look up. If I have 1, 2, I give a simple one, and 2, 4, they are confirmed parallel. Why? Because this is 2 over 1 is 2, right? 4 over 2 is also 2. Okay, they are parallel already. So you will say 1, 2, you times 2 is actually 2, 4, right? You say since this is this, therefore they are parallel. Understand? Now, if I give you a 1, 2 and a 3, 4, can you see this is 3 over 1? What is this? 4 over 2 is 2. Will they be parallel? Then you say you cannot find a constant when you multiply, they are equal. Understand? Therefore, they are not parallel. Are you clear with what I'm saying? Okay? Alright, good. So that is for this part here. Now, next, look at part B. Let's look at part B. Write down 2 vectors that are parallel to this. One in the same direction and one in the opposite direction. Okay. This is quite easy. Negative 5, 2. What is the parallel one that I can have? I can have negative 10, 4. I can also have what? Negative 15, 6. They are parallel, right? What will be one that is parallel but is in the opposite direction? It can be 10, negative 4, right? Because I put a negative in front, the other direction. Agree, class? Okay? So if you look at the answer, okay, it's exactly what I've said. Alright? 2, this one, then opposite direction, you take the negative of it. Even if you take the negative of this one, it's fine. It's the same magnitude. Can you see what I'm talking about? Okay? Alright, now I just want you to look at one question that is practice now 12, number 2 at the bottom. I want to teach you how to do this. Okay? I'm not using the textbook method because it's very confusing. Okay? Alright, now look at question 2, all of you. I want to take out the answer in the textbook. Given that 4 minus 3 and 12p are parallel vectors, find the value of p. All of you look up, please. You will take 12 over 4 equals to what? P over what? Negative 3. You understand? You always do this. So 4p is negative 36, right? So what is p? Negative 9. Can you take down this 4p? This is how you do it. Rather than to go and find a scalar is very difficult. Do you understand what I'm talking about here? Yes or no? Yes, Okay, so the answer is negative 9. Can you use this method always when they tell you it's parallel? Just take this over this and this over this. It will be correct. Okay? Alright. Now, next thing. Let's take a look at this particular question. Example 30. Wow. If A is this and B is this, express 2A plus 3B as a column vector. I think it's very easy, right? It's just matrices. Blah, 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 you have this. Now, I find when I mark your 5A, a lot of you have this problem. You just put A is this, which is wrong. When it's a vector, you must have twiddle below. You forget, you must put the twiddle below. Understand? Okay, so can I leave this alone? You already know. Now, if U is this and V is this, and this is this, find the value of X and Y. Now, do you agree this is again matrices? Can see? Okay, so I'm going to just show you the answer. You just minus, present, after that you solve the equation, you'll be able to get the answer. Are we okay? That's why I told you matrices is very much tied to vectors. Just the vectors is simpler, it's only a column vector. Okay? Alright. I just want to know, are we clear so far? Are we clear so far? Okay, good. Now, next part. Expression of a vector in terms of two other vectors. Now, this one is just for your info. Okay? Now, I want you to look at this particular picture here. All of you look up. Figure 510 shows two non-zero and non-parallel vectors u and v and the vector AB. This is AB, this is V, this is U, alright? Okay? Alright, what did the question want us to do? Can you turn to the next page? Can all of you turn to the next page? Okay? To express AB in terms of U and V, we start from the point A and draw a line parallel, so on and so forth, okay? Then you will get the answer down there. Okay? Alternatively and so on. Now I'm going to show you on the board what it means. Understand? I'm using this picture. Will that be okay? Now all of you look up. Can you see this is V? V is a horizontal vector, right? With how many units? 3. Now, I have 3. We will go until here, right? This is actually 2V. Do you agree? Now you look at this one U. It's 1, 2, right? Can you see it's 1, 2? Now if I from here, 1, 2, you'll be here, right? This is U. 1, 2 again, right? 1, 2 again. So up here, what is this? 3, right? 3, right? Actually, AB is 2V plus 3U, you can see it. Do you understand what I'm talking about? Okay? That means they want you to express this in terms of this. So this is how you do it. Now, is this the only way to do it? Is this the only way to do it? Now, I know you're bored. That's why I say whether first lesson or last lesson, it makes no difference. You're still sleeping. Wake up. Wake up. Yes. Or else I'll translate you out of the class. Okay? Now, can you see that I can also have this? 1, 2, 3. This is 3U. You see? I can also have this. 1, 2. This is 2V. Remember I told you the parallelogram law? Okay? So AB is actually 2V plus 3U, or it can also be what? 3U plus 2V. Do you understand what I'm talking about here? Can or cannot? This is expressing one vector in terms of two other vectors. Okay? Alright, so if you turn to the next page, page 199, all of you turn to page 199. Okay? They show you both. Okay? They show you both. Okay? So, this part is actually expression of a vector in terms of two other vectors. Okay? Just for your information. Now, I want you to look at the next page here by the side. Here. U plus 2V is actually 2V plus 3U, and vector addition is commutative. Commutative means you flip the order, it doesn't matter. But if it's subtraction, it's not commutative. Understand? Okay? Alright, so are we clear so far? Are we clear so far? Okay, good. Now, next, what it means is this. AB can be written as MU plus NB, right? Depending on what's the number. Okay, how we draw it. Okay, next one that I'm going to is called position vectors. This one is the one that is important. Okay. Now, if I have a point A that has coordinate 2, 3, okay, the position vector is actually OA. That means from the origin to that point, and it is 2, 3. X coordinate on top, Y coordinate below. Understand? So if I have the coordinates, I can write down the vector. If I have the position vector, I can also write down the coordinates. Vice versa. Is that understood? Okay, position vector is with respect to the origin. Okay, alright, now let's take a look at this particular part here. All this actually I've done it before already. Okay, I just want you to look at the next page here. This one is important. Okay, the position vector of P, xy, which is OP, is xy. That means from the coordinates I can get the vector. From the vector I can get back the coordinates. Okay, now this one is very powerful in column vectors. Position vector, what I mean is OQ minus OP. Remember I told you before? This one? But now it's O. Why? Because its position vector is with respect to the origin. So it's O. Do you agree that I can also have AQ minus AP in other instances? Okay, but this time I use O. Why? Because it's with respect to the origin. Everybody okay? Alright, now, so on and so forth. Actually, we have done all this before already. It's just that now they want to give a name to it. Okay. Now let's look at example 14. Because I only have example 14, then I need to tell you something about collinear and so on. Okay, what do you mean by collinear? Okay. Now let's take a look at this example 14. This is the last example. Can I have you to wake up, please? Okay. Ryan, wake up. Don't sleep like that. Your hand is not the pillow. I have not seen such a thin pillow before. Okay, now let's take a look at this one. All of you look at, I'm not going to do it the same way. You may or may not be the same. Write down the position vector of P and of Q. Okay, what do we have position vector? P is 2 minus P, right? Position vector will be OP, right? So it will be what? 2, negative 3, column vector. Okay? Now, Q is 4, 1. So OQ will be 4, 1. These are the position vectors. Are you all clear? Then they say, express PQ as a column vector. Okay, this is fantastic. This is easy. This is just OQ minus what? OP. Good. So it will just be 4, 1 minus 2, negative 3. What will this be? 2, what? 2, 4, right? 2, 4. So PQ will be a column vector 2, 4. Everybody clear? Okay. Now, a point A is translated by the translation vector AB to a point B. Find the coordinates of B. What do I mean by that? Okay. This one looks a bit difficult, but actually it is not. Can I clean this off first? Okay. Alright. Now, they tell you A is minus 5, 3. That means OA is what? Minus 5, 3. Then you translate it with this, right? That means I'm adding this to it, right? Correct. Okay, to a point B. So what do I do? Okay, find the coordinates of B. Now, you look at this. Wait, I'll just show you first. Do you agree that the question tells you AB is 9, negative 6? And I know OA, right? Everybody okay? Okay, repeat. The point A, which is negative 5, 3, is translated by the translation vector AB, 9, negative 6 to a point B. Find the coordinates of B. Now, all look up. Can you see that AB is actually OB minus OA? Now, AB is 9, negative 6, right? OB we don't know. Then minus 5, 3, right? Can you see we have done it like matrices like that? Okay? So, OB will be 9, negative 6 plus this one, right? Bring over become plus, right? Correct. So, what would this be? 4 what? 4 and negative 3. Now, then I want to tell you, if OB is 4, negative 3, what is the coordinates of B? 4, negative 3. You must write properly. Understand? No? Coordinate means coordinate, column vector means column vector. Understand? So, you will get the coordinates of B as 4, negative 3. Are we okay so far? Are we okay so far? Okay, good. So that's all for this part. Huh? Now, then I need to say something about collinear, because in the exam, right, O levels especially, they will always tell us what we mean by collinear, right? This one, actually in your A-Max, the teachers will talk about it last year when we do coordinate geometry. Okay? Now, am I right? Okay? There must be two conditions. First of all, you must say that it has the same gradient, and this is the common point. Now I need to stress this. It doesn't mean that it has always got to be B. It can be AB and AC have the same gradient. So what's the common point here? What's the common point here? A. It can also be AC with BC, same gradient. Then what's the common point here? C. Understand? Now, I repeat here, I'm talking about gradient here. Do you agree that if I talk about vectors, that means the two must be parallel? Same gradient means parallel, right? The two must be parallel and there must be a common point. Agree or not? You cannot just say parallel and no common point. Then they are not collinear. Collinear means lie in the same straight line. Understand? Lie in the same straight line. Why is that so? I will illustrate to you. Are we done with this? Are we done with this? Okay, huh? Okay, I want to show you something on the spot. Because some people say, why do we need a common point? All of you look up. All of you look up first. If I have AB, okay, then I have a BC. They are parallel vectors. Okay, they are parallel vectors. They are parallel means they slant the same way, right? And there's a common point B, right? What does it mean? That means I can connect and extend this to C, right? That's why they must have the same gradient and there must be a common point. Okay? But this is not the only case. I can also have this. For example, can you see that I can also have this? They are also parallel, right? Parallel means what? Same gradient. So if this is the common point, I can actually draw this here and B length somewhere here, right? So what's the common point now? A. Do you understand? Likewise, I can have C. Okay? So to prove collinear of 3 points, that means they lie on the same straight line. First of all, you must prove gradient the same. Gradient the same means parallel. Okay? And there must be a what? Common point. You cannot don't have the common point. If without common point, class, it's parallel but no common point. It's just different lines. You cannot coincide. There's no join. Do you follow what I'm saying here? Okay? Okay, Alright, then that's very good. Okay? Now, next, this is what I want to do. Can you take out a square paper? All of you take out a square paper. You have one more square paper only, actually, okay? I'm going to show you one example and you're going to do the rest of it for me. Will that be okay? Alright. Take out the square paper. You have one more left. Can all of you look at question number 9? illustrate each of the following on a sheet of square paper. Okay. Now I want to look at 3B. Okay. Sorry, not 3B. What's that? 9B. Now class, I don't want people to do anything first. You listen to me first. I'll let you draw later. Okay, no problem. Alright? Now, if I don't need to draw, right, I can just say 3. Right? So this is actually a negative 3, 3 plus a 2, 4, right? Which will give me a what? Negative what? 7. Agree with what I'm saying? Can or cannot? Can. Okay. Why did I say I do this? Because I want to check the answer later. Okay, now all of you look up. I need to draw this. What is this sign here? Plus. Plus means what? I start again, right? Okay, all of you look up. Please don't do anything. 3A. Now let's draw A first. I start from here. Negative 1, 1. That means this is A, right? 3A, that means I must have 3 times of that, right? Agree with what I'm saying? Don't draw. I say don't draw. Okay, I'll give you time. Now, then I must plus 2B. Plus means I start there, right? What is this? 1, 2. So, from here, 1, 2, right? Alright, how many times of it? This is 1, 2, right? Correct? How many times of it? 2 times. So, I will have another 1, 2 up. Correct? Now, this is a bit strange. I draw somewhere here. This is weird. So, 3, this is negative 3A. This is 3A. Correct? Then 1, 2, 1, 2 will be here. So, the 2B will go this way. Correct? How come it looks so funny? 3A, did I make a mistake? Did I make a mistake? Huh? Did I make a mistake? Oh, I make a mistake because A is up. Hey, I made a mistake, must tell me now or not. I do until so hard, then you tell me it's wrong. Okay, come, balik again. Start from here. Negative 1, here, right? Correct now. So it should be like this. Alright? 3A. Then 2B. Correct? Then this will be my what? Correct? Now I want to check. When I do it numerically, I'll have negative 1, 7, right? Now let's start from here. Can you see? This 3A plus 2B start from here. Negative 1, 1, 2, 3, 4, 5, 6, 7. I'm correct. You understand what I'm talking about here? Yes or no? Okay, can you draw this first one first on your square paper? Yeah. You don't have already? Oh, I don't know whether I have. I'll check. Yes, you're lucky. Right. This is your 9B. What? Hey, when I give you, you better 珍惜, I tell you, I better treasure it. Because I photostat until want to die with you, okay? And I secretly photostat one. I want you to look at 9B. After you've done that, can you do this numerically for me first? Can you tell me the answer? Negative 5? and negative what? Negative 8. Negative what? 4. Correct? The answer should be negative 5, negative 4. Now, okay, all of you look up. Because the last part you're going to do yourself. What is this sign here? Minus. If it's minus means both must start both in the same point. Okay. I'm going to do this. 2a. This will be my 2a, right? Alright. 3b. I must start from the same point, right? Agree, class? 3b. So, okay? Now, what minus what? 2a minus 3b. So must point at where? 2a. I must point at 2a. That means okay. Now, what is this answer? Minus 5, minus 4, right? So I count. I start from here. Can you see this is the originator for the vector? So 1, 2, 3, 4, 5. 1, 2, 3, 4. Can you see it's negative 5, negative 4? Everybody clear? This is your second diagram. Everybody okay? Can or cannot? Can, huh? Okay, good. Then you look at N. Negative 3a plus 4b. Now, there are two ways to do it. And I want you to do it both ways for the diagram, but not for the working. Working one way will do. Okay, now can you do the working for me first, this one? Is this correct? Is this 7 point? Okay, now I want to draw both on the square paper. I want to tell you why is that so. Now, do you agree that minus 3a plus 4b, I can draw it like that? Or I can draw 4b minus 3a, it's the same. Everybody clear now? Okay, now hold on first. Let's draw this one first. Negative 3a. So I will draw 3a first. This will be 3a, right? Negative 3a means what? The direction is flipped, right? Do you all agree? I'm talking to you. Yes? So it becomes like that, right? Alright, I'm drawing situation 1, scenario 1. Then what is this? Plus. Plus means I must start, right? Then 4b, right? So 4b, here. 1, 2, 3, 4. This is my 4b. Plus means it will go this way. So it's 7, negative 5. Let's check. 1, 2, 3, 4, 5, 6, 7. And 5. 1, 2, 3, 4, 5. 7, 5. So it's correct. Can you see? Okay, can you draw this and write down this as the resultant vector? All of you do case 1 first. All of you do this. Case 1. Draw on your square paper. Now, then I want you to draw this yourself. It's minus. So what will happen? It will originate from the same point. Okay, all of you draw scenario 2 yourself. I want to see that your resultant is the same. Everybody here? Wait down. if I want to draw the second one, I must start from the same point, right? Correct. 3A, 4B must start from the same point, right? Because it's minus. May I know my resultant point at where? It must point at D, right? Because B is the starting one. Can you see? So this is actually 4B minus 3A. You will see that the resultant is actually the same. Can you all see what I'm talking about here? Okay. Now I want you to compare the two diagrams. What is the only difference? The direction of this one, right? Can you see? Can you see? This is the other way, then you add, then it becomes this. This one is at originate and minus. It will also be the same answer. Can you see what I'm talking about here? Yes or no? Yes or no? Okay, so that will be your question number 9 on the square paper. Are you okay? Are you okay? Okay, now you turn to the back of the square paper. We'll continue from there. Okay, what number is it on your content page for E-Max now? Number what? Now write what? Right, 1, 5. Now write 1, 5 or 1, 6. 1, 5. Okay, 15. Just write scalar multiples. Okay. I want on foolscap. Not foolscap, fine. Back of square paper. Now, if back of square paper not enough, then of course must staple foolscap lah. Understand? Huh? I want question 5, 7, 8C, 9, 11, 12, 14, 15. But 9 we have already done it already. Because it's on the square paper. Everybody okay? Everybody okay with what I'm saying? Okay, now let's take a look at question 5. I will start together with you. Will that be alright? Okay, then the rest, you will do it as your HBL tomorrow. So you don't have to log into Google Meet. Will that be okay? Because I also want you to have time to revise for your other things as well. Okay? Alright, now let's take a look at this particular question. Question number 5. I only have a few minutes. So let's take a look at question number 5. If P, Q, and R are points, respectively, expressed as column vectors. Okay. Number 3. I want to write now P, now, if I have this info, right, what does it mean? OP is what? 3 negative 2. What about OQ? 2 negative 4. What about OR? 2, 3. This is what you should write down whenever you have this type of question. Remember I said the coordinate will be the position vector just now? I'm talking about question number 5. Did I write wrongly? I write number 3 now. Okay, I write number 3 about. So question number 5, a mistake. Everybody okay? Alright, now let's take a look at the question here. Part 1. I'm not going to do for you. PQ, do you agree is OQ minus OP? Then you can do it already. Am I right? Next one, part 2. What about QR? Just tell me first. Go right. O what? OR minus OQ, right? What about part 3? RP. OP minus OR, right? Okay. Part 4. Have you copied this already? Have you all copied this already? Please copy. Part 4. PR. OR minus OP. Now, actually, I want to tell you this. There's no need to find PR. I can get the answer from here. Why? Just a negative of it. Do you get what I'm talking about? You can do this, or you can say PR is just the negative of RP. Then you just take negative of the one, then you can get the answer. Okay? Can? Alright, so can you do number 5 for me first? Now, all of you. Stop the video, Trisha.